Okay, let's talk about atomic number for just a minute. Again, tells us the number of protons in a nucleus, also the number of electrons, as I've already stated, and typically the number on the top of the symbol on the periodic table is your atomic number. Okay, atomic mass. This is the number of protons plus the number of neutrons. When we solve for the number of neutrons, we round the mass number to the proper place that we're supposed to. And then we subtract atomic number from atomic mass. Again, as I've already told you, that would be the way to figure out the number of neutrons. So for example there, you have aluminum. It would be the atomic mass of aluminum, which we would round to 27, 26.981 would round to 27. We subtract our atomic number, which is, you see above the symbol there, 13, which would give us the number of neutrons for aluminum, which is 14. So some practice. Okay, the element lithium, the symbol Li, the number of protons is 3, so that's also the number of electrons. The number of neutrons would be 4 because of the atomic mass. And we remember the atomic number is also the number of protons and the number of electrons. So remember, to find our neutrons, which we said was 4, we had to take 7, our atomic mass, and subtract our atomic number. Okay, Br, that would be bromine, has 35 protons, 35 electrons, because our atomic number is 35. The number of neutrons would be 45, so if we say the number of neutrons plus our atomic number, which tells us the number of protons, that would give us an atomic mass of 80. Potassium, symbol K, has 19 protons, which means we have 19 electrons. It has 20 neutrons because when we take 39 and subtract 19, we get 20. And so therefore we also know that our atomic number is 19. Sodium, Na. Okay, it tells us the number of electrons, so we know that the number of protons is also 11. We take 23, our atomic mass, subtract 11, so we know we have 12 neutrons. We also know that because we had 11 protons and electrons, that is our atomic number. Argon, Ar. It has an atomic number of 18, so that means we have 18 protons and 18 electrons. 18 plus 22 tells us that's the atomic mass of 40. Silicon, Si. We know our atomic number is 14, so that's 14 protons, 14 electrons. And because our atomic mass is 28, that means we also have 14 neutrons. Alright, element symbols. There's two different ways that we see this most often in chemistry. You have hyphen notation, which you see in your example there of helium. You have an element symbol, and then you have a hyphen, and then you have the mass number rounded to the nearest whole number. So your example of helium, you would see the element symbol He-4 because helium's mass number rounded is to 4. Then you also have nuclear symbol, and that would look like the example at the bottom. Again, we're using helium. You see a superscript, which is the mass number. That would be the number on top. You see a subscript. That would be the atomic number, the number below the mass number. And then you would see the symbol, which is He. Isotopes. These are atoms with the same number of protons and electrons but have different numbers of neutrons. They are the same element, they just have different masses. And all isotopes are used to calculate atomic mass. This is the reason why all atomic masses that we see have a decimal. And most elements on the periodic table consist of a mixture of many different isotopes.